The Zoom session is being brought to you by the Fractal Piece Roots. All right, now, well, okay. Where were we? Yeah, okay. All right, there's not much more to be doing. I've posted the final, etc. It's due by next Thursday, the 26th, though I'd prefer it if you got it in a little earlier. You know where, scan it and put it in through the inbox like this. All right, now for now, I think what I'll do is cover some of the extra credit sets, specifically these three: stereo, tree height, and antenna on the roof. Stereo. Okay, this is about stereo vision. Here's one eye, here's another eye, here's the object. They're both eyes are focusing in on. They both have to point inwards to both focus on it. And there's a known distance between the two eyes, that's C. There's a known angle alpha, there's a known angle beta. And so from these deduce A, B, and the distance D. Okay. Now, okay, there's I have another problem set, tree height, maybe that'll be next one. Okay, so alpha, A equals D over sine beta. And B equals D over sine alpha. That's basic right angle trigonometry. Cos 180 minus beta is minus cos beta. Sine 180 minus beta equals sine beta. So, so if you use some basic law of sines work, you'll get that. Well, after a bit of work, you get that D equals C sine alpha sine beta over sine of the sum. A equals C sine alpha plus beta. That's law of sines. B equals C sine beta over sine of alpha plus beta. Again, law of sines. When else you add in this stuff here. So, okay. We give some angles, a distance. What's the distance D? What's angle A? What's distance A? What's distance B? Okay. Related to that is this problem set. Excuse me. Why is this taking so long? Okay. Tree height. Here's a tree of height h. Evidently, I imagined it as a pine type tree. Here's you observe it from a certain distance x, and it has what's called an angle of elevation called beta. You retreat a distance c, and of course it's smaller on the horizon. So, and it has a smaller angle of elevation alpha. We're given alpha, c, and b. Find h. So okay, let's go through the derivation. X plus c over h is cotangent of alpha, adjacent over hypotenuse, cos alpha over sine alpha. X over h is cotangent beta, cos beta over sine beta. Therefore, you take the difference between the two, x over plus c over h minus x over h. That's cos alpha over sine alpha minus cos beta over sine beta. This left side simplifies to c over h. Right side, we combine fractions, c cos alpha sine beta minus cos beta sine alpha, or sine times sine. Excuse me, that's tiresome. Okay, so if you invert both sides, that's h over c is sine alpha sine beta over cosine sine minus cosine sine, which if you work out is sine of beta minus alpha underneath sine alpha times sine beta. Then transposing the c, you get h equals c sine alpha sine beta over sine of beta minus alpha. That's the height of the tree. All right, so again, here's some examples. Given a couple of angles and a distance c, angle c, angle c, angle c. Find height h. All right. Both of these were law of sine problems, essentially. Here's one which it's an unusual one of its own. All right, here's a building of height b. You move off a height distance c and look at it from there. And here's an antenna of height h. How high is h? We're given b and c and alpha. Beta we're not given. We'll figure it out later. But find h. All right. So that's given alpha, b, and c. Find h. So building is height b, back off a distance c, and the apparent angle subtended by the by the antenna is alpha. Find the height of the antenna. Well, okay. Well, okay. We threw in a new variable beta. Its tangent is b over c, and this has an angle of alpha plus beta. Now height here h plus b. So tangent of alpha plus beta is h plus b over c, like that. So if you take the difference between these two, h plus b over c minus b over c, this minus this, that's tangent of sum alpha plus beta minus tan beta. All right, now left side, after some cancellation, b goes away. We're left with h over c. That's tan alpha plus tan beta over 1 minus tan alpha tan beta. That's the sum of tangent of a sum. All that minus tan beta, right? So, and tan beta is b over c. Tan beta is b over c. Replace it in here, and then you place it here. Then simplify this fraction here by multiplying above and below by c. So h over c equals c tan alpha plus b over c minus b tan alpha. All that minus b over c. Then you multiply both sides by c. You get c squared tan alpha plus bc over c minus b tan alpha. All that minus b over 1. The c is multiplied here and here. It cancels here. Okay, we're good. We have an expression for h. Then we expand this out a bit. And c squared tan alpha plus bc minus bc minus b squared tan alpha. All right, there is a common factor of tan alpha between these two terms. And these two terms cancel out. So if h equals c squared plus b squared tan alpha, or c minus b tan alpha. And if you multiply above and below by tan alpha, cosine alpha, excuse me, you get c squared plus b squared sine alpha over c cos alpha minus b sine alpha. That's an expression for the length of the antenna on the roof. I suspect there's some, you can probably go further. This looks like a square of a length. In fact, square of this length here. And these look like the kind of thing you get when you add a cosine or some such, but let that be. So we're given an angle alpha here, 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 and here, a b here, c here, from that find h. Okay, that will be each of these problem sets are extra credit problem sets. All these problem sets are extra credit. Do it at your leisure. Get them in by before the 26th. Oh, and by the way, starting, let's say tomorrow, I will not be sending back any sets of errors. If you hand something in, I'll just tell you your score and not say what you can do. So there'll be no chance of retake after Friday. It's simply a matter of the rush of events for me. That's how it has to be. Okay. Well, there are others. Here's one of my favorites. Oh, I did mention that. We did do pendulum. I'd like to mention this one, and then we'll call it a day. Here, Pythagorean triples. Okay, a Pythagorean triple is a right angle triangle where all three sides are whole numbers. Okay. Now, one of the classic ones is the 3, 4, 5 triangle. 3 squared plus 4 squared is 9 plus 16 equals 25, which is 5 squared. So a triangle with sides 3, 4, and 5 is a right angle triangle. And there are others of 5, 12, 13, and so on. In fact, it turns out that if m and n are whole numbers, then this identity applies for all m and n. M squared minus n squared plus 2mn squared equals m squared plus n squared. So this m squared minus n squared, 2mn, and m squared plus n squared form the sides of a right triangle. And if m and n are whole numbers, then so are these three numbers. So yeah, that would give you a what's called a Pythagorean triple. So here we go. Here's the right triangle. If you set m equal 2 and n equal 1, you get the 3, 4, 5 triangle. If you set m equal 3 and n equal 2, you get a 5, 12, 13 triangle, which is indeed a right triangle. 5 squared plus 12 squared is 25 plus 144, which is 169, or 13 squared. Now, if you do 4 and 2 for m and n, you get a 12, 16, 20 triangle, which is indeed a Pythagorean triangle, but it's sort of redundant because it's simply the 3, 4, 5 triangle, only 4 times bigger. 3 times 4 is 12, 4 times 4 is 16, 5 times 4 is 20. So here's a 3, 4, 5 triangle. Here's a 3, 4, 5 triangle. Here's a 12, 16, 20 triangle. just 4 times bigger. Similar triangles with the same angles here and here, here and here, here and here. So here's some extra credit points. Prove this. Just go through the algebraic steps. What happened is that you expand this, you'll get a term in the middle of minus 4m m squared n squared, and that will cancel minus, excuse me, 2m squared n squared. This will cancel it to make it this. So prove that for a point. For 4 other points, find 4 Pythagorean triples that are not similar to the 3, 4, 5, or the 5, 12, 13, or each other. So I will not accept 12, 16, 20, or let's say a 10, 24, 26 triangle. But if they're not similar to each other or those two, then each of those would be worth a point. Okay. Well, all right. There are a number of others. Perhaps I'll mention them on Tuesday and Thursday next week. But I think we can't do. Oh, here's one I really liked. Tangential addition. Now recall, okay, we define t of plus. I call that tangential addition as tangent of sum of arctangents. Okay. Now you can use the angle addition formula for tangent to prove this one. The tangential sum of x and y is x plus y over 1 minus xy. For problem 2, I ask you to simplify a ratio of integers, tangential addition of a over a, t plus b over b. It'll be a simple enough expression, just use this. And from 3 and 1, simplify this. Xt plus yt plus c. Then from that, prove associativity of t plus, so that the way you group together t plus doesn't matter. Also commutativity, that the order of t plus doesn't matter. Xt plus y equals yt plus x. So t plus already has a couple of the rules of ordinary addition. Also, xt plus 0 is what? Xt plus negative x is what? Prove negative of xt plus y equals negative xt plus negative y. So negative distributes over t plus. So far, it's looking a lot like ordinary addition in a number of ways. Also, number 9 has to prove transposition. Xt plus a equals b means that x equals bt plus negative a. Now, I've seen people just from here then expand out through this and then do a bunch of algebra to prove this. That's not strictly necessary. All you really need is to use 8 and 3 and 7, and everything will fall out. Basically, you treat t plus like addition, like ordinary addition in an ordinary transposition. But what happened? 10, simplify associativity for t plus, or to express t plus for rational fractions. You get an expression in a, b, and c divided by another expression in a, b, and c. Here, number 11, prove that tan alpha t plus tan beta equals tan of alpha plus beta. That follows straight from number 1 and the rule of tangential addition, addition of angles for tangent. Okay, 12, root 3t plus root 3t plus root 3. What is it? I'll leave that for you to figure out. 2 minus root 3t plus 2 minus root 3t plus 2 minus root 3 equals what? It would help if you use number 11 and find what this root 3 is the tangent of and what this 2 minus root 3 is the tangent of. Here are a couple others. Xt plus infinity is negative 1 over x. What is xt plus 1 over x? Prove that negative 1 over xt plus negative 1 over y equals xt plus y. And that should do for now. Okay. So that's worth a few points, 16 points if you do it. I've seen at least one person in this class who has basically done all the extra credit sets and was guaranteed an A simply because of the sheer number of points that's accumulated. This and this and this are also worth a few points. And this, if you do these problems correctly, basically fill in a table, then it's worth up to 24 points. The difficulty being that is is that I require exact values and also to reduce and do reduced radical form. So there'll be no square roots in the denominator. Okay, there's enough for that. Okay, we're past the edge of the book. I'm giving you how to make some points even more than in the book. So I think we're pretty much done, at least for now. You have some homeworks and quizzes in the final to do. So I will be here for the next week, basically running an office hour, more or less like this one. So I open the floor to questions, requests, comments, and suggestions.
Yes, a question. So there's no limit on the amount of extra credit we can turn in?
Turn them in all.
Nice, okay, gonna try.
I'm a great believer in people and encouraging people to go beyond.
Okay.
I said.
That sounds good. Thank you, Professor. That's actually really good.
You're welcome.
Professor.
Yes.
Question. Did you upload the extra credit class to YouTube?
What?
Let me type the message. I can't speak well, so.
Okay. Fine. Into the chats. Did I? Okay. Well, all right. More questions? Did you load the extra credit class video? I believe I did. It's, well, let me double check. It should be on the, you want to look in here, EC Zooms. Okay, there you'll find from here and from previous years. Okay?
Okay, got it. Thank you so much.
Not a problem. More?
No, I'm glad Keon Tang asked where the YouTube videos were because I was wondering too, but I was gonna try and figure it myself.
Okay, I
Now we know.
I should have said so. It was a little obscure, and that is a bit of a shame. Too bad. Sorry about that.
No, that's all right. Thank you.
Sure, no problem. Okay, more questions? All right, well then, motion to adjourn. Is it seconded?
Seconded. Yeah.
Good. Well, it's been real and complex. I hope to hear from your finals soon enough, and I shall be grading them directly. Good morning to you all.
Good morning to you, Professor. Thank you for class.
Thank you.
Thank you.
It's been real.
Thank you for being such a good professor.
I hope I have been.
I have a question. Do you by any chance teach calculus?
I've
never.
No, I have never taught calculus at this school, it turns out, because I've settled on a particular band of classes. This, algebra, sometimes statistics, sometimes business math, which has a little bit of calculus, but not much.
Yeah. You don't recommend any professors at City College for calculus?
I wouldn't know. Sorry about that.
It's okay. I had to ask. All right. Thank you.
Thank you, and a good day. That worked.